Okay, we are still choosing between linear and exponential models, but we're going to now jump to task 4 in your book. Here we have Brooke and Phoebe have both made an investment of $1,000. So they're initially investing $1,000. Brooke invested in a bond, while Phoebe invested in a certificate of deposit, which is short for CD. So if you hear of bank CD, that's a certificate of deposit. The tables show their values of their investments each year. Write functions that model the values of each investment. And then we want to graph those models. Okay. Well, what's really nice about these two is they give you the difference in the ratio so you can compare. Here, if we look at Brooke, we can tell that the difference between each of these is always 40. So since it has a common difference, that tells me that Brooke's investment is linear. So y minus y1 equals mx minus x1. So it's that linear model. So let's go ahead and let's create that. Let's create that linear model. Again, I need an x1, y1. Pick any of these. I'm going to pick this first one, this guy right here. So I would have y minus my y1, which is 1,000. Slope. What is the slope here? Well, this goes up by 1 each time. And this goes up by, well, they give us the difference here, up by 40. So my slope would be 40 over 1, which is 40. X minus x1, which is 0, because I'm using this point right here. You could pick any point. That's just the one we used. X minus 0 is x. So we would end up with, and then if we add the 1,000 to both sides, y equals 40x plus 1,000. And at this point, it's always nice to check to make sure this should work for any single one of these points. So when I input a 5, I should get out 1,200. Oh, sorry. Let's bring the calculator up. So when I input a 5, meaning when I take 40, let's go back to my home screen, second mode, which is quit. 40 times 5 plus 1,000, I should get that 1,200, which I do. So that tells me that my equation does in fact work. The only thing we might want to change now is if you notice the variables. They're saying my input is time, my output is V. So we would probably want to rewrite this into V equals 40t plus 1,000. So there's our equation. And we can then graph that either using our calculator or sketch it, y-intercept of 1,000. So y-intercept up here of 1,000. And then go up 40 over 1 each time and graph that equation in. It'll be a nice little line. And we only want positives because it's investment. We're not going to go into negative time. Okay. All right. The next one, they give us, it does not have a common difference. Each one of these is different. But it does have a common ratio of 1.307. So since it has a common ratio, I know that this is going to be exponential. So my exponential function in function notation, f of x equals a times b to the x. There's our standard. My a is my starting point, which we know is 1,000. And what do we multiply by each time? Our growth factor is 1.0375. So we're multiplying by 1.0375 to the x. So there's my equation. And it's always a good idea to check it like we did with the last one, meaning when I put in a 5, I should get out 120210. So if I bring up my calculator, I take this equation and I take 1,000 times 1.0375 to the 5th. I get 120209, which rounds, if you look behind it, 9, it rounds to 10 cents. So yes, that equation does in fact work for that one. And that one has a common ratio. And we can talk about this further. This one, the common difference is 40. This one, the growth factor is 1.307, but the growth rate or the interest rate for hers would be 1.0375 minus 1. How much more than 1 is it? It would be 0.0375. So she invested this in an account that has 3.75% interest. That is her interest rate or growth rate. Okay, is how much more than 1 it is.